Hey, everybody, and welcome to Gant's Picks for AI FYI. All right, for today, I have an awesome pick. Are you great at Sudoku? 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 Sudoku. Well, I don't know. I'm not that great at it, but this is cool. Awesome coder and YouTuber Atomic14 solves Sudoku in the browser. Check this out. It's all open source code. So you can actually take a look at this right now. There's a website for you to go ahead and click on, and then immediately you could use your phone or you could use your laptop, and then you could point this at a normal Sudoku puzzle and then solve it immediately. What a cool use for not only computer vision, but the application of TensorFlow JS, which is really cool because normally when you solve something like this, you don't get a chance to easily show it to everybody. But with TensorFlow JS, you get this kind of cool immediate gratification of sending off a link so that people can try out your code. Now, with this great source code is an amazing tutorial on all the process that's happening so that you can understand exactly how it's doing it. That video is available on YouTube, and there's one part of it that was amazing to me, and that was the part of binarizing images. That's taking an image that you don't really care about the RGB values for and simplifying it down to either 255 or 0 for the color of the pixels. So I thought to myself, let's go ahead and see how something like that actually works. So if you take a look at the code and we dig into it, because awesome, it is open source, and we take a look at the source right here, we can go into augmented reality, image processing, and we can see here that we have this adaptive threshold for binarizing the images. And it's quite simple. We have a blurred version of the image, which we're getting from a box blur. Looks like there was originally an attempt with a Gaussian blur as well, but a box blur should do because it's nice and fast. And then we subtract that blurred image from the regular one to give us a threshold of whether or not a pixel should be 255 or 0. We do that with a nested for loop of iterating over all of these pixels to find out whether or not that passes the threshold for a image that should be a white pixel or a black pixel. I really love this method, and I love that this is open source. One of the things that I noticed is that this is actually not using some of the cool tricks that we can use in TensorFlow JS. So I decided maybe we could show you just a little bit of how you could do a simple version of this. And if you're interested, I could do the blurred version as well. But I think you can kind of solve that for yourself if you want to. So, why is Atomic 14 using a blur in order to go ahead and adjust the threshold for whether a pixel should be white or black? Well, he explains this in the video, but just to make it sort of succinct, we're going to go here on Tensor Playground and we'll just do a quick demo of just taking a look at something. And if you take a look at this image here, which is a grayscale image, you can see that the bottom right is a lot darker than the top of the entire image. So if I'm just going to pick a threshold, let's say any pixel that's less than 50 out of 255, I'm going to get some part of the image which is going to be nice and binarized, and some part of it which is not going to be. But as I said, let's just go ahead and do the simple version like I just described. And then if you're very interested, we could go ahead and come back and do it with a blurred image. To do this with TensorFlow JS, let's take a look at what we have here. We have a tensor that's coming in, and it is a int32 tensor that's coming through here. So this int32 tensor, we're going to go ahead and we're going to identify whether the pixels are between some amount. I said 50 earlier, so let's go ahead and use 50. If it's below 50, it'll be one color. And if it's above 50, it'll be another. And then we'll adjust that threshold and see how the image adapts. So in order to do that, I'm going to go ahead and get a collection of white pixels and a collection of black pixels that are the same dimensionality as this image. Now I could code in TF1s for 684 by 1024, or I could go ahead and do ones like. So let's use ones like because that'll be dynamic and work with any image that we have. So let's go ahead and code that real quick. If I was going to say const a light version of this, TF1s like a tensor, which is coming in, this light right here, if I return that, I should get a whole bunch of ones by this tensor shape. And if I run that, you can see that it comes back as a black image. At first, you might be like, oh, that didn't work at all. But then we see our top left and bottom right pixel colors are all of the value 1. So it looks like the value 1, of course, does not mean a white pixel in an int32. It means a white pixel for a float. So as type float 32. And now this turns into a white pixel image because we're using floats here. Now let's go ahead and get a black, which will be const dark equals tf zeros like, and that'll say give it something just like that shape. And I don't need to say as type here because, well, 0 is 0 and both 0 to 255 and 0 to 1. So if I return dark here, I should get a completely black image. And these are, of course, the same dimensionality as the input vector, which is this monochrome tensor that's coming in. Now's the part where we can just do this simple comparison. And to do that in TensorFlow, we can do that with tf.where. And tf.where simply comes in. Let me go ahead and say const simple, because this is a simple version of what's happening inside the Sudoku puzzle, but it's nice and easy. I could say, all right, let's start this off with tf.less. And so this is the condition of a where. So there's, this is a lot like, we're basically looking at a ternary here. So what we were saying earlier is less. So if we say a tensor is less than 50, and that'll be our threshold, then I want you to return a light pixel. And so that'll return the corresponding light pixel, which is all ones. So this is saying just return a 1. And then for any particular pixel that is where this is false, return the dark pixel. And if I return simple here, we can actually see what we're doing. So anything less than 50, we will show a 1. Otherwise, we will show a 0. And let's see what that looks like. Okay. So now here we have, this is an inversion of the image. I can move this to greater than or flip the dark and the light, but it doesn't matter. It kind of explains the point here. And if we take a look at what we've got for this image, you can see that it's pretty clear. The top is very sort of like hollowed out, and then we get some definition on the windows, but see this clock here is hard to see. And then we get a little bit of seeing the fences and the definitions coming around at the bottom. So if I move this from 50 to 100, however, and let's run again, well, now we're seeing extreme definition on the clock, but we're all washed out at the bottom right. So proof is there that we need to go ahead and use that special method that was identified by Atomic 14. But instead of actually iterating over all the pixels, we can leverage something cool like TensorFlow's where, and this is probably a lot faster because this is happening inside the GPU, whereas this was happening in JavaScript. But yeah, we've got the idea. We were able to binarize an image based off of a specific threshold. And if you're interested in doing the blurred version where it'll give us detail throughout the image, reach out to me on Twitter. It's at GantLabord, and we can code that up real fast if you'd like as well. Messing with media is really fun, and the cool thing about tensors is that we actually get to draw on these images and see this kind of cool stuff. I hope you enjoyed some extra code in this session along with my pick. Let me know what you think about that. And also, this episode is sponsored by the Cloudinary MDE program. As we're talking about images and video and information, don't forget to check out all the Media Developer Expert program from Cloudinary, the cool people there. It's a great group. I think you should totally apply to join. And if you do get in there, say hi to me. Thanks so much, everybody. That's Gant's Picks. I'll see you all next time.